Once again, welcome to my channel viewers. We'll discuss here a few important sums on the properties of parallelogram. This we are taking from class 9 curriculum Cbse. Now, question number 1, in parallelogram ABCD, 2 points P and Q. These 2 points P and Q are taken on diagonal BD. So that DP equal to BQ. That means this part equal to this part BQ. Now we have to prove that triangle APD, this triangle, and triangle CQB, this triangle, they are congruent. Then we have to find that AP equal to CQ, AP equal to CQ. That means if we can prove that these two triangles are congruent, then they will be equal by virtue of CPCT. Corresponding parts of congruent triangles are equal. Again, we have to prove that triangle AQB, this triangle, congruent to triangle CPD, this triangle. Then AQ equal to CP, AQ equal to this part equal to CP. Then we have to prove that APCQ is a parallelogram. APCQ, it's a parallelogram. Now, if we can prove AP equal to CQ and CP equal to AQ, that means in quadrilateral APCQ, opposite sides are equal. That means it would be a parallelogram, right? So let us try it out. So first, now you see in these two triangles, consider these two triangles, APD and CQB. In triangles APD and CQB. Let us consider this triangle CQB, this triangle, and APD, this triangle. You find that AD equal to CB. Why? They are opposite sides of parallelogram. Opposite sides of parallelogram. Since we are given that ABCD is a parallelogram, opposite sides are equal. So AD equal to CB. Then we are given that DP equal to BQ. This is given. In our question it is given DP equal to BQ. So these two sides are equal. Then we find that angle ADB equal to angle CBD. Why? They are alternate angles, right? You see if you draw separately, you find this is A, D, B, C. Now opposite sides of parallelogram are parallel. AD parallel to BC, then BD is a transversal, so these two angles are equal, alternate angle. Now what is ADB? ADB means for this triangle ADP, that is angle ADP equal to angle CBD means CBQ, angle CBQ, right? So in these two triangles we find that two sides and included angle they are equal. So these two triangles are congruent. Therefore triangle ADP, or you can say APD congruent to triangle CQB by virtue of side criteria, right? These two triangles are congruent. Now in congruent angles, corresponding parts are equal. That means this part equal to this part, right? Therefore AP equal to CPCT. Corresponding parts of congruent triangles are equal. Now let us come to these two triangles again. These two triangles here. Triangle again in triangles AQB and CPD. Let us come to these two triangles. You see AB equal to CD. They are opposite sides of parallelogram, right? Opposite sides of parallelogram, right? AB equal to CD. Then you find BQ equal to PD or BQ equal to DP, right? BQ equal to DP. You can write BQ equal to DP. This is given in our question. Given. Then you find these two angles are equal since they are alternate angle, right? So if you want to draw it separately, then you find that these two angles are equal. This is DCAB. ABD equal to angle CDB. They are alternate angle. Angle ABD equal to angle CDB, alternate angle. Now what is ABD? ABD means angle ABQ. For this triangle, angle ABQ. ABQ equal to angle CDP. CDP. So we find that in these two triangles, these two sides and included angle of this triangle are equal to two sides and included angle of this triangle. So these two triangles are congruent. Triangle A, B or AQB congruent to triangle CPD by SAS criteria. Now if they are congruent, corresponding parts are equal. AQ equal to CP. Why they are equal? AQ equal to CP, CPCT. Corresponding parts of congruent triangles are equal. AQ equal to CP. So this one is proved, right? Now, therefore, in quadrilateral AQCP, in which we find that AQ equal to CP and AP equal to CQ, this we proved earlier, right? So in this quadrilateral, you see AP CQ, we find that AP equal to CQ, right? This we proved earlier. Then we again prove that AQ equal to CP, AQ equal to CP. So opposite sides are equal, therefore AQCP is a parallelogram. Right? So AQCP is a parallelogram. Why? Or APCQ is a parallelogram. Why it is parallelogram? Since because opposite sides are equal. So it's a parallelogram. Now we are coming to question number 2. ABCD is a parallelogram. Here ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C. This is AP perpendicular on diagonal BD, CQ perpendicular on diagonal BD, right? Now we have to prove that triangle APB, this triangle congruent to triangle CQD. These two triangles are congruent. We have to prove that. Now let us come to these two triangles, how they are congruent. You see, these two sides are equal, opposite sides of parallelogram are equal, right? This is given. Then you find this angle equal to this angle. Why? They are alternate angles, right? Then you find these two angles are equal. These two angles are equal, 90 degree. So by AAS criteria, angle side criteria, these two triangles are congruent. If they are congruent, corresponding parts are equal, so we will find that AP equal to CQ, right? So let us prove this. In triangles APB and CQD, we find that AB equal to CD, opposite sides of parallelogram. Opposite sides of parallelogram are equal, so AB equal to CD, we find it. Then we find that angle APB equal to angle CQD, each equal to 90 degree. Since they are perpendicular, AP perpendicular on BD, CQ perpendicular on BD, so they are right angles. Angle, you see ABD equal to angle CDB, alternate angles, right? You see, they are like CDBA. These two lines are parallel, opposite sides of parallelogram are parallel, CD parallel to AB, and then diagonal BD is a transversal, so these two angles are equal. Now ABD means, what is ABD? That is angle ABP. For this triangle, we can name this angle as ABP. Then angle CDB means CDQ. Therefore, these two triangles are congruent by AAS criterion. Therefore, triangle APB congruent to triangle CQD. AAS criteria, right? So these two triangles are congruent. We can check the corresponding parts here. So it is P, and this is A, this is B. This is Q, C, D. So you find that AB equal to CD, right? AB equal to CD. Then you find these two angles are right angles, right? Then you find BAP equal to DCQ or CDQ. BAP, BD. So ABP, angle ABP equal to angle CDQ. These two angles are alternate angles, right? Since these two sides are parallel, so BD is a transversal. These two angles are equal. Now this angle means here this ABP, this angle, and this angle means here you find CDQ. So two angles and one side are equal to two angles and one side of this triangle, so they are congruent by AAS criteria. Now if they are congruent, we can write AP equal to CQ. Corresponding parts of congruent triangles are equal, CPCD, right? So this has to be proved. Now Finally, come to question number 3 here. ABCD is a trapezium in which AB parallel to CD. This line parallel to CD. And you also given that AD equal to BC. That means it is an isosceles trapezium. Two side circle, non-parallel side circle. So it is an isosceles trapezium. We have to prove that angle A equal to angle B. These two angles are equal. Then we have to prove that angle C equal to angle D. Right? So, and diagonal AC equal to diagonal BD. Diagonal AC equal to diagonal BD. They are also equal. So we are given that AB parallel to CD. These two are parallel. Then AD equal to BC. Now let us prove. Now we'll try to make it a parallelogram here. So let us extend this side. Then we'll draw a line from C parallel to AD. Say it is E, suppose. So we got a parallelogram here. ADCE, it's a parallelogram. Let AB is extended to E so that AD parallel to CE. Means we are extending this side AB to an external point E so that this line, when you join CE, you find that this line is parallel to AD. Therefore, ADCE is a parallelogram. Why it is parallelogram? AB was parallel to CD by definition here. AB parallel to CD. That means AE parallel to CD. Then by virtue of our construction, additional construction, we find it AD parallel to CE. So opposite sides are parallel here now. So it's a parallelogram. ADCE is a parallelogram, right? Now in a parallelogram, opposite angles are equal. Therefore, angle DAE equal to angle DCE. Opposite angles of parallelogram. Opposite angles of parallelogram are equal. DAE means angle A. For the original drawing, DAE means angle A. And DCE equal to DCE. DCE is, what is DCE? DCE, you can write DCB plus angle BCE. BCE. That means this angle equal to sum of angle DCB plus angle BCE. Right? So angle A equal to angle DCB plus angle BCE. Right? Now you see, originally these two sides are equal, and by construction we find that it's a parallelogram ADCE. So this side equal to this side, so these two sides are equal. That means it's an isosceles triangle. So these two angles are equal, right? These two angles are equal. You find angle DCB plus angle ABC equal to 180 degree. Why? Because these two lines are parallel. A, B, C, D. these two angles, sum total of these two angles is 180 supplementary. These two lines are parallel, it's a transversal, so interior angle on the same side of the transversal are supplementary. So we find that angle DCB plus angle ABC 180 degree. Interior angles on the same side of the transversal. DCB means angle C actually. In original drawing it is angle C. And ABC means angle B. That is angle C plus angle B equal to 180 degree. For the original drawing, this is B, C, A, D. DCB means this angle, ABC means this angle. So angle C plus B 180 degree. Right? Now you see angle C, that means DCB equal to this angle, right? Angle C means angle EBC. Angle C means angle EBC. EBC plus angle B equal to 180 degree. Since angle C equal to C means DCB. DCB equal to angle EBC. They are alternate angle. Right? AE parallel to DC, BC is a transversal, so these two angles are equal, alternate angle. EBC equal to angle B equal to 180 degree. Now what is EBC? EBC equal to angle CEB, CEB plus angle B equal to 180 degree. Right? Why they are equal? Since these two sides are equal. Since CB equal to CE, therefore angle EBC equal to angle CEB. These two sides are equal, so it's an isosceles triangle. So angles opposite to equal sides are equal. These two angles are equal. That means EBC can be replaced with CEB. Now what is CEB? CEB means angle D. Angle D plus angle B 180 degree. Right? Angle D plus B 180 degree. Now you see angle D plus B 180 degree, you find again angle A plus angle D 180 degree. Why angle A plus D 180 degree? These two lines are parallel, so interior angles on the same side of the transversal 180 degree. So now you compare these two, therefore angle A plus angle D equal to angle B plus angle D. Now from both sides you can cancel D, that is angle A equal to angle B. So we find that angle A and B are equal, right? Angle A and B are equal. Now can we prove angle C and D are equal? Can we prove angle C and D are equal? Let us prove this. How can we prove angle C and D are equal? Angle C means BCD. Angle D means ADB. You find that angle A plus D 180 degree, angle B plus C is also 180 degree. A and B are equal, therefore C and D are equal. We find that angle A plus angle D equal to angle B plus angle C equal to 180 degree. Right? Why they are 180 degree? You see? These two lines are parallel, so interior angle on the same side of the transversal is supplementary. Therefore, A plus D 180 degree. Similarly, angle B plus C, interior angles on the same side of the transversal are supplementary, B plus C 180 degree. Now angle A plus angle D equal to, B means angle A plus angle C. Since we proved that angle A equal to B, so in place of angle B we can say angle A. Now you can cancel A on both sides, therefore angle C equal to angle D. So this has to be proved, right? Now let us come to triangle ABC and triangle BAD. ABC and BAD. This is A, B, C, D. We prove that angle in triangle ABC, this angle equal to triangle BAD, this angle. Since angle A and B are equal, so these two angles are equal. This is a common side. These two sides are equal. We are given. So if you separate out these two triangles, the picture will be more clear. You see, A, B, D. Then you draw another triangle. This is A, B, C. AB equal to AB, common side. Then you are given AD equal to BC. This was originally given. Then we already proved that angle B equal to angle A. So these two triangles are congruent. In triangles ABC and BAD, we find that angle ABC equal to angle BAD, since angle A equal to angle B. This was proved earlier. In first case we proved this. AB equal to BA, common side. AD equal to BC, this was given. This is common side, right? Therefore triangle ABC congruent to triangle BAD by side angle side criteria. Now if these two triangles are congruent, that means these two sides will be equal, right? Cpct, therefore BD equal to AC. Cpct, corresponding parts of congruent angles are equal, right? BD equal to AC, that is diagonal AC equal to diagonal BD, diagonal AC equal to diagonal BD. So this has to be proved, right? So thank you viewers for watching this video. I hope these problems will be very helpful for clearing your concepts. We'll discuss some more examples in the next class again.